Chapter 6. Primes, the building blocks of the natural numbers. The natural numbers are the numbers 1, 2, 3, and so on. These numbers start from 1. For instance, you know 2 times 12 is 24. Then the number 2 and 12 are called divisors of 24 because they are natural numbers that divide 24. Now let's write down all the divisors of 24. 1, 2, 3, 4, 6, 8, 12, and 24 are divisors of 24. Now again, let's write down all the divisors of 23 and 25. The divisors of 23 are 1 and 23 only. The divisors of 25 are 1, 5, 25. The divisors of a number are factors of that number. A factor of a number is a number that divides it exactly. Therefore, the divisors of a number, as we have said, they are factors of that number. They are called factors of that number. A factor is also, it is a number that divides it exactly. A number that has only 2 factors is called a prime factor. A number with more than 2 factors is called composite number. 1 is neither prime nor composite. It is an exceptional number. Therefore, a number that has only 2 factors is called prime number. You may take an example, this 23. 23 is a prime number. It has only 2 factors. A number with more than 2 factors is called composite number. You may take this example, 25. It has more than 2 factors. Therefore, 25 is composite number. And 1 is neither prime nor composite. It is an exceptional number. Example, find the factors, this means divisors, of 168. Solution. To find the factors of 168, let us use multiplication tree. That is, first we write 168. 168 divided 2 is 84. Again, 84 divided by 2 is 42. 42 divided by 2 is 21. 21 divided by 3 is 7. This one is called multiplication tree. Therefore, the factors of 168 are 1, 2, 3, 7, 21, 42, 84, and 168. You may take 1, 2 from this 2, 2, 3, 7, 21, 42, 84, 168 are factors of 168. The numbers to the left of the tree are called prime factors. The above examples are called the prime factorization. From the above example, factors of 168 are 1, 2, 3, 7, 21, 42, 84, and 168. The number 168 is called multiple of the numbers 1, 2, 3, 7, 21, 42, 84, and 168. And the numbers 1, 2, 3, 7, 21, 42, 84, and 168 are called the factors of 168. Multiples of 2 are 2, 4, 6, 8. That is 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8, and so on. These are called multiples of 2. Again, as we have said, these numbers are factors of 168. And 168 is a multiple of the numbers 1, 2, 3, 7, 21, 42, 84, and 168. Exercise. Write down the first 5 multiples of each of the following. We are going to find multiples of these numbers. A. The multiples of 3 are 1 times 3, 2 times 3, 3 times 3, 4 times 3, 5 times 3. These are 3, 6, 9, 12, 15. B. The multiples of 4. 4, 8, 12, 16, 20, and so on. These are the first 5 multiples of 4. C. The first 5 multiples of 5 are 5, 10, 15, 20, and 25. D. The first 5 multiples of 6 are 6, 12, 18, 24, 30. E. The first 5 multiples of 10 are 10, 20, 30, 40, 50. I hope the explanation is clear for you. Greatest common factor, GCF. Example. Find the factors of 16 and 24. Solution. Factors of 16 are 1, 2, 4, 8, 16. 16 can be divided by these numbers exactly without remainder. Factors of 24 are 1, 2, 4, 6, 8, 12, 24. Now 1, 2, 4, 8 are common factors of 16 and 12. Thus, factors are common factors for 16 and 24. Eight is the greatest common factor, that is GCF, of 16 and 24. Simply to find GCF, we prime factorize the numbers. That is 16. 2 times 2 times 2 times 2. That is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 24. The prime factors of 24 are 2 times 2 times 2 times 3. That is 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Then GCF of 16 and 24 is, we take one of those two. Again, we take one of those two, this common 2. And again, we take one of those 2. That is 2 times 2 times 2 is 8. We can find also like this one using this method. Other method to find great common factor, that is GCF of 16 and 24, is as follows. First, we find the prime factors for both 16 and 24. That is, first we write 16, then comma 24. The prime factors for those two numbers, the minimum prime factor, that is the lowest, is 2. 16 divided by 2, again 24 divided by 2. That is 16 divided by 2 is 8. 24 divided by 2 is 12. Again, for 8 and for 12, the least prime factor which divides those two numbers without remainder is 2. 8 divided 2 is 4. 12 divided by 2 is 6. Again, we divide these numbers by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Then we stop here and we don't have any prime factor which divides these two numbers exactly. Therefore, the last step is 2 times 2 times 2. That is 2 times 2 is 4. 4 times 2 is 8. 8 is the GCF of 16 and 24. Next is least common multiple, LCM. Example, find the least common multiple of 16 and 24. Solution. The multiples of 16 are 16 times 1, 16 times 2, 16 times 3, 16 times 4, 16 times 5, and so on. Therefore, multiples of 16 are 16, 32, 48, 64, 80, 96. Multiples of 24 are 24, 48, 72, 96, 120, 144, and so on. Therefore, the least common multiple LCM of 16 and 24 is 48. This 48 is common for the multiples of 16 and the multiples of 24, and it is the least common multiple. Second method for finding LCM of 16 and 24 is using prime factorize the number. That is, for 16 and 24, the least prime factor is 2. They can be divided by 2 without remainder. Then 16 divided by 2 is 8. 24 divided by 2 is 12. Again, 8 and 12, they can be divided by the least prime factor 2. 8 divided 2 is 4. 12 divided by 2 is 6. Again here, let's divide it by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Here we don't stop like the GCF as we have done in the GCF, finding the GCF. We continue up to 1. 2 divided 2 is 1. We write 3. And 3 also divided by 3. It is 1. Finally, we multiply. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48. Therefore, LCM of 16 and 24 is 48. As we have found here, it is 48. Exercise. Find the GCF and LCM of 42 and 60. Solution. Let us use the second method, that is prime factorization. To find the GCF of 42 and 16, let's divide first by 2. Then 42 divided by 2 is 21. 60 divided by 2 is 30. Again here, 21 and 30 can be divided by 3. 3 is another prime factorization for 21 and 30. Then 21 divided 3 is 7. 30 divided 3 is 10. We stop here. Then 2 times 3 is 6. This 6 is GCF of 42 and 60. LCM for 42 and 60. Let's use the prime factorization method. 42 divided by 2 is 21. 60 divided by 2 is 30. Again, 21 and 30 can be divided by 3. 21 divided 3 is 7. 30 divided 3 is 10. Now we divide 10 by 2. It will be 5. Again, this 5, let's divide it by 5. Prime factor for 5 is 5. It will be 1. Now this 7 also should be 1. 7 divided by 7 is 1. Now 2 times 3 times 2 times 5 times 7 is 420. LCM of 42 and 60 is 420. Number 2. Find the GCF of the following. Question A, 12 and 18. Question B, 9, 15, 63. Solution. A. GCF for 12 and 18. Let's use the prime factorization. Now 6 and 9 can be divided by prime factor, which is 3. 6 divided 3 is 2. 9 divided 3 is 3. We stop here. The prime factorization, we stop here. 2 times 3 is 6. 6 is the GCF of 12 and 18. GCF for 9, 15, and 63. These numbers can be divided by 3. 9 divided 3 is 3. 15 divided 3 is 5. 63 divided by 3 is 21. And we stop here since there is no common prime factor for the 3 numbers. Therefore, the GCF of 9, 15, and 63 is 3. Number 3. Find the LCM of the following. Question A, 4, 8. Question B, 12, 18, 24. Solution. LCM for 4 and 8 will be, let's divide these numbers by 2. 4 divided by 2 is 2. 8 divided by 2 is 4. Let's divide again by 2. 2 divided 2 is 1. 4 divided by 2 is 2. 2 divided by 2 is 1. Now we have reached 1, 1. Therefore, 2 times 2 is 4. 4 times 2 is 8. 8 is the LCM of 4 and 8. B. LCM of 12, 18, and 24. Let's divide it by 2. 12 divided by 2 is 6. 18 divided by 2 is 9. 24 divided by 2 is 12. Let's divide these numbers by 3. 6 divided 3 is 2. 9 divided by 3 is 3. 12 divided by 3 is 4. Now let's divide by 2. 2 divided 2 will be 1. 3 will be as it is. 4 divided by 2 is 2. Let's divide it by 2 again. 1, 3, 2 divided 2 is 1. The last one is, let's divide it by 3. 3 divided 3 will be 1. Then it will be 1, 1, 1. Then the LCM for 12, 18, and 24 is 2 times 3 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 3 is 72. Number 4. The GCF and the LCM of 30 and X are 30 and 900 respectively. Find the value of X. Here the GCF and the LCM of two numbers are given. One of the numbers is 30 and the other number is unknown, which is X. The GCF is 30 and the LCM is 900. Find the value of X. That is, find the value of the second number. Solution. Let us say the first and the second numbers are Y and X. Then the product of two numbers is equal to the product of their GCF and LCM. That is, Y times X, those are the two numbers, Y times X is equal to GCF and LCM of those two numbers. GCF times LCM of those two numbers. You should recall this formula. Therefore, 30 times X is equal to, 30 is the first number, the second number is X, is equal to, the GCF is 30, LCM is 900. Then 30 times X is 30X is equal to 30 times 900. Let's divide both sides by 30. It is 30 divided by 30 is 1. 30 divided by 30 is 1. By 30, it will be 1. 30 divided by 30 is 1. Then the value of X will be 900. The second number is 900. Number 5. The GCF and LCM of 12, 18, and X are 4 and 48 respectively. Find the value of X. Solution. The numbers are 12, 16, and X. GCF is 4 and LCM is 48. Factors of 12 are 1, 2, 3, 4, 6, 12. Factors of 16 are 1, 2, 4, 8, and 16. Factors of the unknown number x is 1, dash, again dash, dash, dash. The last one will be x. Multiples of 12 are 12, 24, 36, 48, and so on. Multiples of 16 are 16, 32, 48, 64, and so on. Multiples of x will be x, 2x, 3x, 4x, and so on. GCF is 4 and LCM is given 48. Here there is no specific formula. We are going to guess the number. From the GCF, one of the factors of the unknown number is 4. Therefore, the number could be at minimum 4. From the LCM, the number is divisible by 48. Therefore, the number is at maximum 48. I hope the explanation is clear. As we have said, from the GCF, one of the factors of the unknown number is 4 here. Here is 4. Again, here is 4. Here should be 4. We guess here should be 4 since the GCF is 4. Therefore, at minimum, the number could be 4. We guess that the number could be 4. And from the LCM, the number is divisible by 48. Here we do have 48. Here we do have 48. And here, one of these numbers, it will be 48. One of the multiples. Therefore, at maximum, it could be 48. Therefore, we don't have any specific answer for number 5. Just we guess the unknown number. That is 48 divided by 1 is 48. The number could be at maximum 48. Therefore, the number is between 4 and 48. At minimum, it could be 4. At maximum, it could be 48. Therefore, the number is, we guess it is between 4 and 48.